Welcome, everyone, to our exploration of a transformative technology that's reshaping industries, sparking innovation, and redefining what's possible in manufacturing. Additive manufacturing. Additive manufacturing, commonly known as 3D printing, is a cutting-edge process that builds objects by layering material one slice at a time. There are many process types and more being developed. These modules will provide you with a 360-degree overview. The advantage of additive manufacturing is design freedom. Design flexibility associated with the additive manufacturing process family allows us to create complex freeform geometries that would be impossible with traditional methods, interlocking features, assemblies. This can be fabricated with the appropriate additive manufacturing process. We only use the material necessary to fabricate the component or associated support structures, reducing waste. Rapid prototyping accelerates development cycles and reduces costs, especially when we're doing several prototype iterations. The process planning decisions for several processes really can be minimized. Therefore, the term rapid prototyping has been used interchangeably with additive manufacturing, digital manufacturing, and 3D printing. For low-volume production scenarios, we can produce customized patient-specific medical devices, such as dental implants or prosthetics. Molds for jewelry can be readily manufactured with intricate detail. Custom tools, jigs and fixtures, and more can be fabricated using additive manufacturing processes. Essentially, with this process family, we have democratization of the manufacturing processes for several, not all, several of the additive manufacturing solutions that are available. We have many interesting problems that have been resolved using different additive manufacturing processes. And here's an example of a couple that are a little different. We have a duck that is minus a foot and is now styling it. This duck has mobility now because there are new feet that have been built to suit. And then unfortunately, we have an eagle. Here we can see that its beak has been shot. With a little bit of reverse engineering and clever design, combined with additive manufacturing and a little bit of fit and finish, that eagle is good to go. Here we are. Here is a specific custom-made prosthetic for an eagle. In the more traditional engineering and manufacturing domains, courtesy of Philips Additive Hybrid, here is a directed energy deposition and machined part hybrid manufacturing that was fabricated actually during the International Manufacturing Technology Show in Chicago. They had a low volume order. They had a customer that wanted a couple dozen pieces, and this order was filled without any specialty casting patterns or welding jigs and fixtures. So these are some examples of some of the design freedom, product variety, and production capabilities that have been enabled with this additive manufacturing suite of solutions. So the learning outcomes for this 360 overview are as follows. First, I want to expose you to the additive manufacturing family of processes, and it is a family, and the design and fabrication cycle. Learning outcomes 2 and 3 are interlinked. We will identify the opportunities presented by each additive manufacturing process as well as the family, but conversely, we also need to recognize the quality issues. There are some unique quality issues associated with the additive manufacturing suite that we will discuss in detail in our process-related modules. Learning outcome 4 is to expose you to and to have you appreciate the associated skills and infrastructure that is necessary to leverage select additive manufacturing processes. For learning outcome 5, where we identify the key cost elements, it's not just purchasing some equipment and plug it into the wall. There is some setup, there is some material handling, some health and safety issues that we need to take into consideration, and these will impact the cost elements. We need to establish a baseline for discussing the different processes. The economics are a key consideration, and it's not just the economics for the machine, but the economics with respect to the area of preparation. There could be some unique safety issues or material handling issues. The time element is not just associated with the process planning, because that's one of the beauties of this process family, is the fact that you make very few decisions at the process planning stage and hit the button and go, but there is time that's associated with the actual fabrication process and the post-processing. We'll briefly discuss the supply chain associated with the materials. We cannot ignore the skills that are necessary. One of the things that it's wonderful that for all intents and purposes that the manufacturing has been democratized, but not for every additive manufacturing process. And if we are doing significant post-processing that requires setup and machining, then we need to have the skill sets associated with people that are familiar with computer-aided machining and CNC machines. We'll have some examples of quality. I think it's very important to understand that there is an interaction between the process type, the machine, and the materials, so you may not get the results that you expect in terms of mechanical and physical performance characteristics. And we'll briefly talk on design for whatever that process is strategies.